All right, today we are talking about angles, arcs, and area of a circle. All right, so let's talk about area of a circle first, since circumference of a circle was kind of the last thing we talked about. The area of a circle is equal to pi times the radius squared. Area of a circle equals pi times the radius squared. Very straightforward, simple formula. If you're given a circle, you just have to determine what the radius is. So if we have circle B and we get a line through the center, or a segment through the center, which is a chord, and that chord that goes through the center is 10 units long, this 10 represents our diameter. All right? So if the diameter is equal to 10, then what's the radius equal to? That's 5. Good. So the area is equal to pi times 5 squared. And in your calculator, set it to second fix 2, which rounds everything 2 decimal places for you. And then you can push the pi button times 5 and hit x squared and then equals. So your area of this circle is equal to 78.54. Pi times the radius squared. All right. Now, what is a way that this question could be asked and it's a little more difficult? Have you noticed the progression in the book is where they start giving you information that you need, but they give it to you indirectly? Could you be asked to find the area of a circle with circumference equal to 21? All right, find the area of a circle. Find the area of a circle with circumference equal to 21. Well, you did these problems the other day where you were given the circumference and you found the radius and the diameter. So in this case, if you're going to be finding the area of the circle, area equals pi times the radius squared. So the first thing you have to do is find this radius. Well, we said the other day that circumference is equal to 2 times pi times the radius. That means that if the circumference is equal to 21, then 21 equals 2 times the pi times the radius. So we said the other day that the radius of a circle is equal to circumference divided by 2 pi. So divide both sides by 2 pi. The 2 pi's here cancel. Now, we said the other day too that when you type this in your calculator and you push 21 divided by, you got to push left parenthesis 2 times pi, right parenthesis, so that you're telling your calculator the correct order of operations. So 21 divided by left parenthesis 2 times pi button, right parenthesis, and hit equals. And get 3.34. So 3.34 is our radius. So now we're going to take this radius and we're going to use it in this area formula. So the area of this circle is going to be equal to pi times 3.34 squared. So now, if you're still looking at your calculator, the 3.34 should be on your screen. You can push the x squared button, and that will square the 3.34, and then push times pi and hit equals. And we get our area equal to 35.09. All right, so that's area of a circle when you are given the radius indirectly. You are given the radius in the circumference. All right, does everybody understand those steps? You have this formula written down. You wrote this down in your notes the other day. You also wrote down that c divided by 2 pi equals r. So if you're given the circumference of a circle, you can find the radius. All right, so any questions there? You got a different answer than 35.09? Okay, so it's going to depend on, your calculator's not set to second fix 2 then. Green button? Green button, fix 2. Green button, yep, 2. All right, and then start over. Because what it's doing on second fix 2 from the beginning is it's rounding everything 2 decimal places. All right, are you using the pi button or are you using 3.14, Hector?
Still got 3.05 and the pi button.
Still got what?
35.05.
Okay, I got 35.09. Did you retype this back in or did you use what was sitting on your screen?
I retyped it.
You retyped it. Try it this way. Try, like, here's the steps I did. I did 21. I did divided by. I did left parenthesis. And I did 2 times pi button, right parenthesis, and I hit equals. And does your screen say 3.34?
Yeah.
Okay, now push x squared, the button, x squared. You got 11.17? You shouldn't type anything back in. The only thing you should have done is pushed the x squared button. Yes, no, maybe. The x squared button's 2 above the 8. Okay, and then you push times pi button and hit equals. Yep. See, if I am using values that are sitting on the screen on the computer and I'm just going to the next step, sometimes the calculator is using some of the values that it's not showing. The 3rd place, the 4th place, some stuff like that. And when you retype it in, it's not using that. So if you've got 35 point something, you're
11.17. I'm really sorry. Was the 11.17 the radius squared?
The 11.17 was the, yes.
When I type in 3.14 times 3.14, it's 11.16.
We didn't square 3.14.
3.34 because it's the radius.
Correct.
And I got 11.16.
It's because you're typing in 3.34 and you're not using 21 divided by 2 times pi. Did you hear it? Are you hearing me? Okay. The reason you're not getting the exact same numbers is because you're not doing the exact same steps that I am. That's all. If you're getting this or something really close to this, you're doing the steps correctly. You're just not doing them in the exact order that I am. So our answers may be off by 100th or a 10th, but you understand the concept and you know how to do it. That's all that's important. Okay. All right. Everybody good on those calculator operations and finding the area of a circle when you're given the circumference? All right. Next, we're going to talk about A central angle of a circle. Is an angle with a vertex in the center of the circle. There's a circle with a center. If we put an angle in this circle, ABC is a central angle. Angle. ABC is a central angle. It's an angle with a vertex in the center of the circle. All right? Real important. The sum of the measures of the central angles of a circle is, what's the sum of the measures of all the central angles of a circle? 360. Very good. Because watch, if I put my pencil on the center of the circle B and I draw another line or segment right here, and I call it D, isn't CBD also a central angle? If I put the pencil on B again and go over here, call this E, isn't DBE another central angle? All right, so look, these central angles, in this case, you've got 1, 2, 3, 4 of them. Those 4 angles form a circle, don't they? They form a circle around the center of this circle. So those 4 central angles have to sum 360. It don't matter if there's 40 central angles in a circle or if there's 2. All right, they got to sum 360. If we get this picture, you don't need to draw it, just watch. If this is 80 degrees, what's this other central angle equal to? 280, right? 280 and 80 is 360. So you can use the angle sum theorem to find out different central angle measures in a circle. If you know 3 of them, all right, right here, let's say that this one is 80 and this one is 150 and this one's 60. What's the measure? ABC is a central angle, and we're going to say with measure of how many degrees? What is the measure of angle ABC right here? Is it? Did you take 360 and subtract all those? 360 minus 80 minus 150 minus 6. You did it in your head, didn't you? I got 70. I got 70 degrees. I used my calculator though. I took 360 minus 80 minus 150 minus 60, and I got 70 degrees because those four angles have to sum 360. All right. Very good. Here we go. We're going to say this. An arc is a portion of a circle defined by two endpoints. So again, if we've got this circle, and let's put a central angle in here. Do you see this portion of the circle? That portion of the circle is arc AC. Red arc AC. That's the symbol for arc. All right. You got two types of arcs. You got a minor arc and a major arc. A minor arc is the shortest arc connecting endpoints. Do you see this blue arc right here? How we put our pencil was on A, and we went shortest distance to C. Everybody see that? If you put your pencil on A, you got two ways to get to C, don't you? You can either go the short route or you can go the long route. Agreed? When you go the short route, it's called a minor arc. Now, if there's point, let's put point D over here on the other side. And we're going to change the color here to green. All right. Now, if we put our pencil on A and we go to C, but we go the long way, we go around this way, right? All the way around the long way, because we had to stop and get a phone charger because we left our phone charger at home. So we had to go the long way to C, all right, instead of the short way. That's called a major arc. A major arc is the longest arc connecting endpoints. Everybody okay with that? Minor arc is the short way. Major arc is when you go the long way. And then finally, we got a semicircle. A semicircle is an arc with end points on the diameter. End points on the diameter. And we're going to say this right here, that arcs are congruent if their central angles have the same measure. And then just as important as that right here, super important, the measure of an arc is the same as the measure of its central angle. The measure of an arc is the same as the measure of its central angle. Here's what I mean by that. If you've got a circle and you've got a central angle here, we'll go ABC again. And then let's go over here with D. All right, and let's say that angle ABC is about 75 degrees. Then watch, the measure of arc AC is equal to what? What's the measure of arc AC? Go ahead and say it. The measure of an arc is the same as the measure of its central angle. So it's 75 degrees, right? There, boom. That arc A to C is the same as the measure of its central angle. All right. Now look at arc CD. If arc CD is 120 degrees, then what is the measure of angle DBC? 120 degrees. Very good. If the measure of an arc is the same as its central angle, then the measure of a central angle is the same as its corresponding arc. Okay? So here's what you just ciphered. This was 75. This angle was 120. All right, and now from that, let's find the measure of angle ABD. The measure of angle ABD. That's this central angle on the back side of all this. So what's the measure of that angle? A little louder. 165? Okay, 165 degrees. So then the measure of arc AD, what's that one? Isn't that the same? 165 as well. Okay? All right, and then finally here we're gonna talk a little bit about arc length. The length of an arc. The length of an arc. Of what happened? Is equal to the length of an arc is equal to central angle divided by 360 times 2 pi r. The length of an arc is equal to the central angle divided by 360 times 2 pi r. Here's how this works. It's much simpler than it looks. Here we go. Let's go with arc M, or central angle MNO, that measures 85 degrees. Now, be careful when you're reading these questions. If you're asked to find the length of arc MO, don't confuse length with measure. The length of MO is how far it is from M to O, not how many degrees it is from M to O. Okay? So look, we need a radius or a diameter. So let's say we get, this is 5 right here. The length of MO arc, MO, is equal to central angle, 85 degrees, divided by 360, times 2 times pi times the radius, which is 5. All right. 85 divided by 360 times 2 times pi times 5. So in your calculator, you can type 85 divided by 360 equals, and then push times 2 times pi times 5 and hit equals again. You should get this. All right, everybody do that in your calculator right now. See if you get the same answer. This is your calculator practice. 85 divided by 360, push equals, times 2 times pi button times 5 and push equals again. Anybody get 7.42? Okay, got some head nodding going on. Anybody not? That's when you shake your head left to right, or you raise your hand and say, I didn't get that. I don't know what happened. Anybody have any questions on any of that stuff? Decent amount of information today, but nothing very difficult. All right, so here's what we're going to do today. Let's see here. This is your practice for today. We're going to do page 125 in your workbook. 1 through 20. All right. Now, if you're at home, this is what you're going to do. Page 125, 1 through 20. When you have finished that, then I want you to open and complete the study guide. Or let's call it Quiz 13 study guide. All right, if you're at home, you're going to do workbook page 125, 1 through 20, and after you finish that practice, then open the study guide under the resources tab and complete it. All right, if you're in class, you're going to complete page 125, 1 through 20, and when you're done with that, you're going to walk over to me and you're going to show it to me in your workbook that it's finished, and then I'm going to hand you your study guide. Clear? Everybody understand the process and what's going on today? Anybody at home have a question about anything that's going on today? You doing page 125 first? When you're done with it, you're doing the study guide. I'm going to upload it here as soon as I end this video. Semicircle. Arc with endpoints on the diameter. Right? It goes halfway around the circle.
Could there be multiple minor arcs?
In the same circle? Yes, sir. Yes, sir. Yeah, you could have almost an infinite number of minor arcs in a circle. All right, any questions from anybody that's e-learning?
Nope.
Okay, if you understand what we're doing today, then you're free to exit the meeting. I'm going to end the meeting. I am going to upload your study guide, and then I will upload these notes to YouTube so you can have them if you need them again later.